Good afternoon. My name is Alejandro Saucedo, and today we're going to be diving into a very interesting talk on accelerating NLP at scale with NVIDIA Triton, Seldon Core in Kubernetes using Tempo. And I'm really keen to delve into quite a lot of different interesting topics that we're going to cover. Just as a reminder, at the top right, you will be able to see a link, which is basically to this presentation, where you will be able to get access to all of the resources, notebooks, and code so that you can try all of these examples yourself. So a little bit about myself. I am engineering director at Seldon Technologies. I'm chief scientist at the Institute for Ethical AI and governing council member at large at the Association for Computer Machinery. Seldon itself is one of the most popular open source machine learning orchestration and monitoring frameworks. So we focus primarily on the management and scale of machine learning models. And the Institute is a UK-based research center that focuses on developing frameworks for the responsible operation and design of machine learning systems. So today what we're going to be doing is we're going to be covering machine learning acceleration at scale. So we're going to be taking this NLP use case, but we're going to try to see about the journey of how do we productionize it and get to a high-performing result. We're going to be taking a GPT-2 TensorFlow model. We're going to optimize it using the Onyx protocol, and we're going to be running it using the Triton NVIDIA server. We're going to be first running it in Docker to test it locally, and then we're going to be able to deploy it to Kubernetes using Seldon. And throughout all of this, we're going to be using this framework called Tempo to orchestrate it. So just to give you an example of what is it that we're going to be doing today, this is basically going to be leveraging the GPT-2 model that you may have come across. This is a transformer-based model which has been trained on millions and millions of websites, which basically does a simple thing, which is taking a particular input and predicting the next word, right? And in this case, you can basically see how, here we have the word, the sentence, recite the first law, and the first token generator is A. Then we take this, again, pass it through GPT-2, and then we get a new token, etc., etc. Now, why are we doing this? So the reason why is because now there has been a trend for, large transformer-based and just general NLP machine learning models that actually require quite a lot of resources and complexities to run at scale. And not only that, not focusing on the complexities, but also focusing on the opportunities. These models, particularly the GPT-2 model, which is a text generation model, has been used in some really exciting use cases. So, for example, this is a text-generated, AI-generated adventure text-based game where you're able to kind of like navigate and interact with different scenarios, as well as different other use cases that we have seen on just general sort of text generation. Of course, today we're going to be focusing on primarily the questions of how, as practitioners, we can actually get something up and running that we can leverage ourselves. The creativity would be left to you, the audience. Now, the how we're going to be achieving this is we're going to be fetching a GPT-2 model using the Hugging Face library. This is going to be particularly the TensorFlow model. We're going to optimize this model using the Onyx framework. And then we're going to be leveraging the Tempo SDK to productionize this model. And what that basically is going to look like is basically allowing us to actually deploy this model as a microservice using the Triton Inference server and be able to then run it locally within Docker and then productionize it in Kubernetes. So this is going to be kind of like hand-holding the entire journey of first running it locally in Python, then testing it in Docker so that we can actually iterate on multiple cycles and then deploying it in a horizontally scalable ecosystem. All with the simplicity of not having to leave the Python interface, right? So that's the key thing. If you're curious to try it yourself, I already shared the link to slides at the beginning. but also you will be able to find in these slides the notebook for the Tempo side, and then the notebook for the deeper sort of like underlying, more complex internals of this. So let's get started by just fetching the model. For this, we're going to be, as I said, using the Hugging Face library. So Hugging Face actually has a very vast range of available transformers and NLP models, and it's very simple to use. The only thing that we have to do is to just import the transformer library, and from there using the actual GPT-2 tokenizer and the actual model itself. And we can fetch the pre-trained models, which basically already has all of the hard work of training it, in some sort of like GPU-based instances, et cetera. In this case, we're going to be able to just, load it locally for us to actually test. So you will notice that we're actually loading two things, a tokenizer and a model. So why are we actually loading two? The reason why is because in order for us to actually send text to the GPT-2 model, we actually need to perform some pre-processing steps. So what does this look like? So first we start with our input text. In this case, it says, "I love artificial intelligence." We first, before we pass it to the model, we have to generate a set of tokens. In this case, basically, it would be a machine-readable representation of each of the words. As you can see here, when we actually run this initial text through the tokenizer, we get the input tokens. As you know, in this case, we would have like those 4 tokens as those machine-readable instances, and then we're able to actually pass it to the model. Now, here you will notice that we're using model.generate and not model.predict. And we will talk a little bit more about why that is. But what you can see here is that with that initial sentence, or these 4 tokens, we were able to generate, in this case, 20 extra max tokens, which basically this is just as much as we can generate before it stops. And here we can then see that we have to convert the output tokens back into human readable text, right? We have to go from machine readable to human readable. And you can see that the actual output that was generated, it says, "I love artificial intelligence, but I'm not sure it's worth," right? So that's basically each of the tokens that was generated from our model. So this is really cool, right? I mean, we were able to very, very easily, with very, very few lines, just get to a point where we're actually experimenting with state-of-the-art NLP machine learning models. Now, let's actually open up what's happening inside of this generate function. And as I had mentioned, every time that you actually run an inference iteration through the model, you actually only get 1 token, right? So we need to somehow be able to generate multiple tokens. Now, the key thing here is that whenever you actually perform a prediction to the GPT-2 model, you actually get a broad range of different tokens, and these tokens will have a probability related to each of them. Now, to simplify things, in the case of the token generation, there are multiple different approaches. But for the sake of simplicity, we're going to be using the approach that is referred to as the greedy approach. And this is basically just taking the token with the highest probability that is generated, right? So we're going to first generate 1 token. We're going to take the one that with the highest probability. Then we're going to send the entire sort of text again for inference. We're going to get the next token, and then we're going to take the one with the highest probability and then repeat until we're happy, right? So that's how we're going to be approaching this generate. But of course, the Hugging Face Transformers library already comes with some utilities that allow us to kind of like abstract this knowledge. But you will see later on that we're going to have to actually implement this ourselves. Now, when we actually ask the question of, okay, we were able to run this locally, and we were able to run it within our Python environment, but what if we actually want to make this actually consumable for other individuals to be able to consume for their own applications, right? In this case, if we wanted to build a text-based game or something like that, we need to make it available for applications to consume. And we actually run into some of the usual deep learning and machine learning challenges, which is basically that you have to often depend on specialized hardware, whether it is GPUs, TPUs, high memory, et cetera, et cetera. There are complex dependency graphs. As you saw here, we actually have a transformer and we have a model, right? So we're going to have some dependencies across the different components, as well as some logic that has to orchestrate them. we may have, once we reach certain scale, some compliance requirements, right? If we're actually generating, data for some particular game or something, we actually have seen in some of the use cases, if anyone is familiar with some of the games that have been created with GPT-2, that often they actually take a turn towards like a darker side, which then often requires the questions of, well, what is the responsibility of the developers to ensure that there is some like perhaps I guess heuristics that ensure that the experience is towards a specific area or not, right? But ultimately there are some questions when it comes to not just NLP specific for the text generation models, but broader for broader NLP use cases. There may be other sort of considerations. And then finally, the reproducibility of components. If you have a new model that you've created and perhaps you release a new version, then you may want to actually be able to revert back to previous versions or rerun specific configurations of a previously deployed model, right? So those are all very important things that actually start introducing challenges at scale. Of course, this talk is not going to be delving into the nuances of that. If you're interested, there are other talks that actually delve into a bit more detail, but we're going to be talking about some of the tools that you can use to actually simplify the entire workflow. Now, this basically, from a conceptual perspective, is the question of how do we go from your artifacts and your custom code, right? Basically, your GPT-2 model, as well as the generation token generation logic, into a fully fledged service that perhaps has all of the logic integrated, and you actually have some, production level service configurations, like what would be perhaps some metrics, some logs, and as I mentioned, there's other talks that I have given as well as in the internet that talk about some of the nuances of like machine learning monitoring at scale, et cetera, which you can delve into. But now we're going to be diving into how do we tackle those. How do we tackle the productionization, the optimization? The first step that we're going to be doing is the step of optimizing the model. The way that we're going to be optimizing the model is using this framework called ONNX. And ONNX is the Open Neural Network Exchange, which provides a unified format to be able to export models that then can actually be highly optimized for specific environments. And we're going to be using this framework called TF to ONNX to convert our previously exported TensorFlow model, the one that we were using that can just be exported using the TensorFlow export function, into what now would be a ONNX model, right? And similarly, we would be able to perform different optimizations, but for now, we're only going to be using that. That will then allow us to say, okay, well, now I have an optimized model. How can I now start kind of, creating some sort of like abstraction so that I can serve it? And Tempo provides us with this very simple to use interface to actually productionize these models. The steps that we're going to be able to leverage with Tempo is the following. So we're going to be able to first just define the GPT-2 model wrapper. And by just simply defining the specific configuration, we're then going to be able to simply run this ONNX optimized model in Docker using the Triton Inference server from NVIDIA. Right, and basically this just brings in massive performance optimizations that we're going to be able to take almost for free without having to do too much configuration around it. This of course is going to be a service, a service with a REST endpoint and gRPC endpoint that we're going to be able to now consume by sending requests, right? As opposed to running locally in our Python environment, we're going to be able to send a request into that. Of course, this is just going to be the GPT-2 model, right? Remember that the GPT-2 model only provides the next token in machine-readable token format, right? So we need the logic that would wrap this interaction so that we can just send it human-readable text, right? So for that, the next step is to define the custom transformer logic. In this case, it's going to be that token generation logic. We're going to be able to say, hey, I want to generate, I want to send you this string, and then I want you to generate the next 10 tokens, right? So that's basically what we're going to be able to do. And similar to the previous one, we're going to just run that in Docker and then test it again, right? So that's going to be quite a simple sort of like deployment. And then finally, once we're happy with how this performs, we're going to then be able to run it, in Triton, in Kubernetes with Seldon Core backend, right? So maybe right now this looks a little bit confusing, but it will become a little bit more clear once we actually go into the hands-on. I also just saw that this says, run in Docker with Triton, but actually the custom transformer logic is going to run on a Python server, whilst the actual GPT-2 model will run on the optimized Triton. So remember that we actually had the transformer and then the Triton. This will become a little bit more obvious now. Okay, so the first step, we define the GPT-2 model wrapper. What does that look like with Tempo? We basically just, use the model class, and we are able to then just specify the model name. In this case, it's GPT-2 model. We're going to then define what the platform is. If you remember, our platform is the Onyx encoding, right? And this actually will, in the backend, just use Triton. And then we're going to then be able to say, well, actually, the artifact is located in this local folder, right? So this is basically where our Onyx folder was exported. And for when we actually later on deploy it into Kubernetes, we're going to be able to easily just put it in an S3 bucket using some of the Tempo utilities, right? So now this is all we need in order for us to actually start taking advantage of the GPT-2 model, right? Which is actually really cool, right? Like this is all we need in order for us to actually start interacting. So now in order for us to run this GPT-2 model in Triton, we have to first deploy this model with Docker. So we actually just have to do from tempo.serve.deploy import deploy local. And we then run deploy local on that GPT-2 model class that we created previously, which now actually just basically runs it in our local Docker runtime and gives us this object called remote GPT-2 model that we can now use to interact with this remote model. Right now, we can actually interact by sending a request, right? So what does this look like? We can take a string and locally, right? If you remember, we have to first convert it into tokens. We convert those into tokens. We create a payload, which in this case is basically those specific tokens. And then we actually send that prediction request of that payload, which then gives us that response, which is, in this case, just a simple token, which we actually have to explicitly get the token with the highest probability, right? So this is basically what we would be doing for the greedy approach. Right now, you don't have to care too much about the logic. You just need to know that the actual next token generated to this is a test was the token off, right? And as you may already be thinking, the actual next step for us, now that we have this model, this GPT-2 model deployed, is basically to generate the logic that will actually, orchestrate the creation of the conversion to tokens, as well as the multiple token generation with the greedy approach, right? I hope this is all making sense. I think maybe this will become a little bit more intuitive once we actually show the custom transformer logic that is going to happen next. So now we actually follow a similar approach, but instead of using the model class from Tempo, we use the pipeline class from Tempo. And what this allows us to do is to actually provide some custom logic. And this would be the custom logic that actually would run whenever you actually send the data to your deployed pipeline, right? So in this case, what's happening, we define the name for our pipeline, which in this case is GPT-2 transformer. We provide the local path where we want this transformer artifact. In the case of this, context, it would be the transformer, the Hugging Face transformer, as well as this custom logic, right? Because we need to somehow provide this to both Docker and Kubernetes. And then we are able to tell Tempo that we're going to be using that GPT-2 model that we defined above, right? And this is really cool because now you're interacting with those wrappers and with that wrapping logic that we defined above. So we were basically saying we're going to use a pipeline that actually depends on other models. In this case, it's going to be the GPT-2 model. And basically, the logic that is going to happen here is that whenever the actual whenever the pipeline gets initialized, we're going to be loading that tokenizer, right, from the pre-trained tokenizer logic that we had and that we are saving here. And whenever you actually send a request, right, in this case, it's going to be like a string. Whenever you receive that string, here is the custom logic that is going to run whenever you actually receive that. And this is where we are going to put all the custom logic. Now, what the custom logic looks like, so this is basically what we talked about. So we want to generate 10 tokens. For each of them, we're going to take the string, we're going to actually convert that string into tokens. We're going to generate that payload, and then we're going to send that to our GPT-2 model, right? Then we're going to receive the tokens with the extra one, and we are then going to convert those that received token, the one with the highest probability, into a string, and we're going to append it into our current sentence, right? So, for example, whenever we pass here, I love artificial intelligence, it's going to first start with that. It's going to send that as a first request. Then we're going to get a token, which perhaps would be, bot, right? So then it's going to append it, and we're going to have, I love artificial intelligence bot. And then it's going to run it again. It's going to generate the next token, and then we're going to append whatever the next token is. So it's going to be, I love artificial intelligence, but until, and then, it's going to do this basically 10 times, or until it actually generates, enough tokens that there's none with high enough confidence, and then it's going to just return it, right? So that's basically what we have in our custom logic. And really, the only thing that we need to do is similar to the previous, logic. We have to just basically, save that artifact and then deploy it with our, similar function, right? So it's basically running deploy local on that pipeline. That gives us the remote pipeline client, and then we're able to just send, instead of that, relatively complex logic that we had before, now we basically just send this predict with a string, right? So here it says, I love artificial intelligence. And then the response that we get is, but I'm not sure if it's worth, right? So that's basically what it replied. So I love artificial intelligence, but I'm not sure if it's worth. So, this doesn't mean really much. We probably have to ask to generate a little bit longer tokens, but you can see that this is all we needed to do. Both the model, the GPT-2 model, and the transformer pipeline are running on Docker. And the only thing that, we needed to do is basically just generate, these clients, deploy it. And, with Tempo, you're able to now interact with those remote models that are deployed in Docker without having to deal with any of the underlying complexity of Triton, et cetera, et cetera. Now, the last step is running in Kubernetes. The great thing about this is that the complexity is, not exponential when it comes to actually moving what you already ran in Docker. The only thing that you need to do is to specify what backend you want to use. And in this case, we want to use the Seldon Core backend, and we want to actually provide some specific configurations in our Kubernetes cluster, just basically for the people that know, their Kubernetes. In this case, it's just going to be the namespace as well as how to actually interact with it. Primarily because, if you remember, we actually defined the specific bucket where we want to upload it. Tempo actually helps us by pushing all of the artifacts and everything that we need in order for us to just not have to deal with any of the complexity, so that whenever we just run, instead of deploy local, deploy remote with those specific options, we basically now have a deployed model that is running in Kubernetes that we can actually just interact with by running our input with that token, and you will have that sort of deployed pipeline with the specific inference graph that is going to perform that custom logic in your remote environment, so that you basically just are able to then have your specific applications interacting with that service. Just, in this case, we can see the response being, I love artificial intelligence, but I'm not sure if it's worth. So it's the exact same thing, but the key thing is that we were able to actually test all of those things, all of those things locally, and be able to actually get all the benefits of that local sort of testing with that state-of-the-art technologies, but at the same time actually being able to scale it. Now, with that, we were able to actually cover how to fetch a GPT-2 model, how to optimize it with Onyx, and then using Tempo to productionize it by running it in Docker using the Triton Inference NVIDIA server, and then actually moving this into Kubernetes and orchestrated using Seldon Core, right? There was a lot of things in this talk, but at least we were able to give an intuition. What I would recommend you to do is to get hands-on to actually cover all of the things that we went through today, so that you are able to actually get some hands-on intuition, hands-on experience on how you're able to actually leverage all of these technologies, and also being able to bring it into the higher level applications, right? So today we covered what is more around the infrastructure. The real fun comes when you actually start putting it into more of those creative uses of those applications that interact with users. As a quick reminder, you can find the slides here, and you will be able to find all of the relevant links. And with that said, thank you, everybody, for joining me on this talk, Accelerating NLP at Scale with NVIDIA Triton, with Seldon Core and Kubernetes. With that said, yeah, please feel free to share or reach out for any questions. Thank you all, and yeah, bye for now.